Mars is a cold, dry, and barren land, exposed to the harsh radiation of space by its thin and weak atmosphere. A world that appears completely lifeless. But was it always like this? For decades, scientists have looked at this planet and wondered, could Mars once have been different? A time when the planet was younger, when its core was hotter, when volcanic activity shaded its surface and helped maintain a thicker atmosphere. A time when liquid water may have flowed across its land, collecting in rivers, lakes, and shallow seas. This leads to one of the most important questions in planetary science. Was Mars habitable in the past? To answer it, we must look beyond the Mars we see today and travel billions of years into its history to uncover the story of a world that may once have had the potential to support life. Hidden beneath this silent surface are clues frozen in time. Carved valleys, layered rocks, and ancient minerals whisper of water and warmth. These remnants suggest Mars was not always a frozen desert, but a planet shaped by powerful internal forces, where energy, chemistry, and liquid water may once have coexisted. And if life ever had a chance beyond Earth, this ancient version of Mars may have been the place where that story began. Billions of years ago, Mars was not the frozen desert we see today. Its atmosphere was thicker, its surface warmer, and its interior far more active. Heat from the planet's core powered widespread volcanic activity, releasing gases that helped build and maintain an atmosphere capable of trapping heat. Clouds may have formed in the sky. Rain may have fallen onto the surface. Water began to flow. Rivers carved paths through the land, transporting sediment into low-lying regions where lakes slowly took shape. At this stage, Mars possessed many of the same ingredients that allowed life to emerge on Earth: energy, water, time. For millions of years, Mars may have remained stable enough for complex chemistry to occur, a crucial step toward habitability. In these ancient lakes and river systems, minerals settled into layered sediments, preserving chemical signatures of the conditions in which they formed. Hydrothermal systems, fueled by volcanic heat, may have provided additional sources of energy. Environments that, on Earth, are known to support life even in the absence of sunlight. If life requires more than just water, if it requires persistence, energy, and protection, then early Mars may have offered brief but significant windows where habitability was not only possible, but likely. If Mars was once habitable, the next question becomes unavoidable. Could life have ever emerged there? Most scientists agree that if life existed on Mars, it likely began as simple, microscopic organisms. On Earth, life appeared relatively quickly once liquid water and stable conditions were present. Early Mars shared many of those same ingredients: water, energy, and the chemical building blocks of life. If these favorable conditions persisted long enough, life on Mars may not have remained simple forever. Over extended periods of stability, microscopic life could have evolved greater complexity, developing structures, ecosystems, and more advanced biological processes. However, Mars's window of habitability was limited. As the planet cooled, its magnetic field weakened, and its atmosphere was slowly stripped away. Conditions on the surface became increasingly hostile, cutting short any long-term biological evolution. If complex life ever began to develop on Mars, it may have existed only briefly before the planet could no longer support it. Today, scientists search for ancient biosignatures, chemical traces, fossil-like structures, or patterns in rock that hint at biological activity. Because even evidence that Mars once supported life, simple or complex, would profoundly change our understanding of the universe. It would suggest that life may arise naturally wherever conditions allow, even if those conditions do not last forever. Despite its promising beginning, Mars faced a critical disadvantage. It was smaller than Earth. As the planet cooled, its internal activity slowed. Its magnetic field weakened and eventually disappeared. Without this protective shield, Mars became exposed to the sun's powerful solar wind. Over millions of years, the atmosphere was stripped away, causing surface pressure to fall and temperatures to drop. Liquid water could no longer exist freely on the surface. Rivers dried up, lakes vanished or froze beneath the ground. Yet Mars did not lose its habitability overnight. The transformation was slow and uneven. Some regions may have remained wet and protected longer than others, offering temporary refuges where water and possibly life could persist. Eventually, however, the balance tipped. The warm, wet Mars of the past faded away, leaving behind a cold, arid world shaped by loss rather than renewal, the silent planet we observe today. If Mars was once habitable, could life have ever emerged there? Scientists believe that if life existed on Mars, it would most likely have been microscopic. On Earth, microbial life thrives in some of the harshest environments imaginable, deep beneath the surface, within ice and near volcanic heat. Early Mars may have offered similar refuges. If life ever appeared, it may have left behind subtle chemical signatures or physical structures preserved in ancient rocks. This is why Mars remains a central focus in the search for life beyond Earth. Robotic missions continue to explore, drill, and collect samples, hoping to uncover evidence of a biological past. Because discovering life on Mars would change how we understand life itself, not as something rare, but as something that may arise wherever the conditions are right. Even if life never advanced beyond microbes, the implications are profound. It suggests that life is not unique to Earth, and that the ingredients for biology, water, energy, and organic molecules may be common throughout the solar system. Scientists study Martian rocks for tiny mineral patterns, chemical imbalances, or fossil-like textures that could hint at ancient biology. Every rover landing, drill sample, and orbiting observation brings us closer to answering one of humanity's oldest questions. Are we alone? The search on Mars is not just about the planet itself. It's a window into the possibilities of life on worlds beyond our own. But no matter what Mars's past was, millions or even billions of years ago, today we see the beautiful red dot steadily shining in the night sky as seen from our home planet, Earth. So, what do you think? Do you believe Mars was once habitable? Could it have ever developed complex life? Share your theories, questions, or even wild ideas in the comments below. I'd love to hear your theories and ideas. And if you enjoyed the video, don't forget to like and subscribe for more space exploration content.